I'm going to give you two common types of substitution questions that you see on the AP Calculus exam in the multiple choice section. The first one, it says if the substitution u equals x over 2 is made, this integral is equal to which of those? So this one comes up, this type comes up frequently. If you think you know what to do, I would like you to pause the video and then give it a try. See if you can come up with an answer. Okay, so the first thing that I want you to notice, and you might, if you ran into a problem and you put B, you might have made a mistake right off the bat. This 2 and this 4 are x values. If you have a dx here, that means that your limits of integration are also x values. Similarly, if you have a du here, it is saying that these limits of integration are u values. So if you forgot to change your limits of integration to u's and you chose b, I would double check your answer. So let's go ahead and work this one out. So if you plug in u equals x over 2, you get 1 over 1 minus u squared over x. And then I'm going to find my dx by doing du equals 1/2 dx, which gives me dx is 2 du. So then I'm going to multiply by 2. And this is one of those weird ones where you do have to do an additional variable change. And I have an x here. You'll notice I have a du here. There is no way of canceling out that x. So that's a sign that I need to substitute backwards in for that u equals x over 2. I do that by moving over the 2, and I actually get 2u is x. So I can actually plug in 2u for the x. And I'm actually going to pull that 2 out front on this step. You will notice that I labeled my limits of integration. They are x's right now, but none of the choices have labeled limits of integration. If that is the case, then you can assume that those are u values. So we need to change the limits of integration to u's. So we do that by our first limit of integration is x equals 2. You're going to take your u value, plug in 2 for x, and your bottom limit of integration is going to be 1. Your top limit of integration, if you plug in 4 for that x, you get 2. So this one becomes 2 times the integral from 1 to 2 of 1 minus u squared over 2u times du. And you'll notice this doesn't look like any of the ones that I have there. However, you will see that there's a 2 on the bottom of my fraction. There's a 2 up here. If you pull out the 2 on the bottom, it stays on the bottom of the fraction, so it ends up being just 1. You can think of it as these 2 canceling out. So we're going from 1 to 2 of 1 minus u squared over u du. And you can see that the answer for this is D. We're going to do one other type of AP problem that you often see in the multiple choice section. I actually didn't give choices this time, but I think you're more likely to see it there than in a free response. So they gave us functions f and g, and they gave us a function table for the values. We would like to evaluate the antiderivative of this function. And you might be looking at this, wondering how you can evaluate the antiderivative of a function where you have two things being multiplied. there actually is a way to do this, and it is by using a U-substitution, because I do have a function inside of another function. This f of x is in a function, and that function's derivative appears in the problem. So those are usually two signs that you're going to do a U. In this case, we are going to do U is equal to f of x. And then we're going to do du is equal to, the derivative of f of x is going to be written as f prime of x times dx. So I end up getting du over f prime of x is equal to dx. So now I'm going to plug some stuff in. So I'm going to take the integral of g prime of u. So I'm going to plug in u for that f of x. Then I have times f prime of x. For the dx, I can plug in du over f prime of x. You can see that those f primes are going to cancel. The one other thing I'm going to do, and I recommend you do it on this step, although if you do it on the next step, that's okay, is change my limits of integration. I can guarantee that if you use 0 and 5, you will not get the right answer, unfortunately, because those are x values, so I have x equals 0, but our function is right now in terms of u. So what we're going to do, since we have something with a du, we are going to change our limits of integration. My lower limit of integration I get by plugging 0 in for that u, so it's going to be f of 0. My upper limit of integration is going to be equal to f of 5. So I'm going to end up getting f of 0 down here, f of 5 up here. And you can see that you get something really, really complicated. So, if you really don't like the method that I'm doing here, by the way, if you're really confused by it, another option is to go through, label it as x equals 0 and x equals 5, and then you can substitute the f of x back in for u at the end. I'm going to tell you right now, this is a tough problem. Whenever they give something like this, a lot of people miss it. It's hard for everybody, so if it's hard for you, don't feel discouraged about it. If you could just try to understand it the best that you can, that's what I would hope for. Okay, so if you take a look at what we have here, you might notice something that looks kind of familiar, and that is a definite integral of a derivative. And if you recall, the fundamental theorem of calculus says that if we have an integral from a to b of the derivative of something, that's just going to be f of b minus f of a. Or you can go like one step less far and just write this as the antiderivative of f prime of x is just f of x evaluated from a to b. Either one is okay with me. You can do it either way. I know that the antiderivative of g prime of u is g of u. Even though we're using a new variable, the FTC is still going to apply. It is going to go from f of 0 to f of 5. And then I'm going to go ahead and plug these in. I get g of f of 5 minus g of f of 0. So now I have I have complex composition of functions. So f of 5 is 3, so I'm going to get g of 3. F of 0 is 1, so I'm going to get minus g of 1. The next thing I have, g of 3, is this 3 right here. And then g of 1 is 10. So I end up getting 3 minus 10 equals negative 7. And if you are looking at this and having these function values as limits of integration, I will show you how you can do it. If you understood this, you can just stop the video. But I will show you how to do it using another method. I'm going to just say method 2. And the other way that you can do this is on the step where you plug in your u. You can still go from x equals 0 to x equals 5. I'm just going to ask that when you do that, that you label them as x values. And so after we do our u substitution, we get g prime of u times du. And then when we do the antiderivative, we get g of u from 0 to 5. Now, before you plug in 0 and 5, you do have to plug in your u, which is f of x. So we would end up getting that. It will give you the same thing that we have right here. So you do end up getting the same thing. It's just going to be set up in a different way. So most likely you will not get a question that looks exactly like this on your exam. You'll get something else that uses like similar concepts. So if you can try to conceptually understand this, that would be great. If you're having trouble understanding this, you're probably not alone. These types of questions usually are missed by many people, but if you can get the concept behind it, you will do well on those types of problems.